Hello, this is Mr. Kingsbury, and I just very briefly wanted to work a few examples for you of how to solve equations using the logarithmic property of equality. Let me remind you, that's the property that says if you have two logs that are equal, and their bases are equal, then the stuff inside the parentheses is equal. This is a great rule or law because it allows us to take something that looks fairly complicated and make it pretty simple. Here's just a simple example. If we have let's say the log base 4 of 7, and I tell you that equals the log base 4 of x, and I want you to tell me what does x equal. Well, if you'll note, the logs are equal to each other. They both have a base of 4. That means 7 equals x. So in this case, I didn't even have to do that much to actually solve my problem. Kind of nice. Now we're going to get into some examples that are a little bit more complex, but the gist of it is always the same. Set the stuff inside the parentheses equal, and from there it becomes more of an algebra 1 level solving skill. So let's just take a look at a couple of these. I want to start with the simple and work to the sublime. So let's start with this. This is example 1, and I apologize for my marker. I'm running out of the good ones, so I need to get some more. So here's example 1. We have the log base 2 of 7x plus 1. That's going to equal the log base 2 of 2 minus x. Note, there's nothing outside the logarithm on either side, so that's good. That means we have a logarithm equal to a logarithm. Excellent. Also, the bases are the same. That must be true as well. Those two things must be true before I can do this. 7x, wow, this pen is really going, plus 1 equals 2 minus x. Now from here, I just need to solve some things, right? There are a lot of different directions you could go. I'm going to just add x to both sides. I'm doing that for 2 reasons. Number 1, my personal preference is to keep the coefficient of my variable positive. The way you do that is you always cancel out the term with the smallest coefficient, in this case, -1. The other reason I'm doing that is I'm not a huge fan of having a number first and then subtracting a variable. Mathematicians tend to like the variable to come first and then add or subtract a constant. So I'm just kind of undoing that all at once here. So -x and x combined to give me a 0, and 2 minus 0 is 2. So on the right side, I have 2. On the left side, 7x's plus 1 more x, remember this is 1x, gives me 8x's. And then we can bring down the plus 1. So now I have 8x plus 1 equals 2. And remember I mentioned at the beginning of this, it didn't really matter which one you canceled first. Well, that's 100% true. But now it does matter. See, anytime you are canceling stuff, anytime you are adding or subtracting things to both sides of an equation in order to create a 0, your goal is to end up with one term less than what you started with. I started with 4 terms. Now I have 3. That works out great. Right now, there are 2 terms in this new equation that if I cancel them, all I will be doing is moving something from one side to the other, and I will end up with the same number of terms that I started with. So how do we know which one to cancel? Well, we look at what we did before. We canceled something that had an x and was on the right. So now we need to do the opposite of those 2 things. Cancel something without an x on the left. That would be the 1. So the opposite of adding 1 is subtracting 1. On the right, 2 minus 1 is 1. On the left, 1 and -1, when you combine them, you get a 0. 8x plus 0 is 8x. So I have 8x equals 1. That's 8 times x equals 1. To undo times, I will use division. Since I'm multiplying by 8, I will divide by 8. On the left side, 8 divided by 8 is 1. 1 times x is x. On the left side, or the right side rather, I could divide 1 by 8. You'll get a decimal that ends. I'm just going to keep it as 1/8. I think that's just fine. I've got no problems with that. If you're just dying to make it a decimal, you can. It's not a big deal. I was trying to remember what that ends up being. It's in the teens somewhere. It's if you did divide it, you would get 0.125. Either one of those is fine. This is a case where the fraction and the decimal are both equally accurate, and you don't need to change anything. You don't need to consider not doing the decimal. If this was a run-on decimal, anytime you get a decimal that goes on forever, whether it repeats or not, please use the fraction. That's always the best move. So that's example 1. And I've explained some stuff, so I'm going to go a little bit faster with this next example, just because I don't want this video to be forever. And yes, I did just change the color because this is a better marker than that previous one. So we've got the log base 9 of 5x minus 2. And that equals the log base 9 of 4x plus 5. Once again, I've got two logs that are equal to each other. The bases are the same. So I can set the two parentheses equal to each other. 5x minus 2 equals 4x plus 5. From here, I am going to subtract 4x. Remember, that's just a personal preference. You can cancel any of these 4 terms that you want. What's important is that on the next step, when you cancel the next thing, you pay attention to what you're doing on this step and you do the opposite of it. So on the right side here, 4x minus 4x is 0. 0 plus 5 is 5. On the left side, 5x minus 4x is 1x. And remember, I can write that as just x. It's a little bit of a shortcut, but that's what I'm going to do. And then we'll bring down minus 2. So I now have x minus 2 equals 5. And I'm hoping that this one is pretty clear, but just to be sure, just to make sure I'm driving home the point, initially I subtracted something on the right side that has a variable. So now I need to cancel something that's on the left side that doesn't have a variable, which would be this minus 2. To cancel that, I will add 2 to both sides. 5 plus 2 is 7. Negative 2 plus 2 is 0. X minus 0 is x. So I get x equals 7. I've got one more for you, and I'm going to take the difficulty up just one notch on this last one because I like to challenge y'all. Thus far, there hasn't been anything outside of the logarithm. And I don't know that we're going to venture too far into that territory anyway, but I did want you to have at least one where there was something outside the log that you had to deal with. I didn't make it too terribly difficult, but I did want to put that in there so you'd see something. So we've got 2 times the log base 4 of 6 equals the log base 4 of 3x plus 9. And once again, I have a log equal to a log, but I have this little 2 on the outside. Now, I recall there's a property that says if you have a coefficient of 2 in front of that, if you have a 2 or any kind of coefficient in front of the log, you can rewrite this and you can move that coefficient and make it an exponent. So I'm going to rewrite this as the log base 4 of 6 squared, and that's going to equal the log base 4 of 3x plus 9. And then I'm going to go ahead and square this since I can. 6 squared is 36. So this is the log base 4 of 36. And that's going to equal the log base 4 of 3x plus 9. Now I have 2 logs with the same base equal to each other. 2 logs, same base, equal to each other. So I can simply set 36 equal to 3x plus 9. Now, we do have a little different solving situation. This is actually more like the second step of solving from the previous two examples. I canceled something then, and then the next step, I'm like, I need to cancel something else, but I got to be specific about it, except I don't have something to reference here. I haven't done anything. So how do we know what to do? Always go to the side with more terms and cancel the term that is a like term to the one on the opposite side. So the right side has more terms, so I'm going to cancel something from here. Which of these two is a like term to 36? Well, 36 has no variable. So I'm going to go with the one that has no variable, which is 9. I'm going to subtract that. On the left, 36 minus 9 is 27. On the right, 9 minus 9 is 0. 3x plus 0 is 3x. So my new equation is 27 equals 3 times x. I need to undo times. The opposite of times is division. I'm multiplying by 3, so to cancel it, I will divide by 3. On the left, 27 divided by 3 is 9. On the right, 3 divided by 3 is 1, and 1 times x is x. We get 9 equals x. Just a few examples for you. No big deal. Just wanted to make sure you guys had that. Please feel free to watch this multiple times. I appreciate your attention, and I'll see you soon in class. Have a great day. Bye.